This is number 31 on page 471, and there's three parts. First, in part A, we have to show that the exponent I raised 2 to get 8, when I add it with the exponent I raised 2 to get 4, I will get the exponent I raised 2 to get a 32. So this exponent is a 3, right? I raised 2 to the third power to get an 8. And this exponent is 2. I raised 2 to the second power to get a 4. So if I add 3 and 2, I get 5, which does happen to be the exponent right here that I raised 2 to in order to get a 32. So then in part B, it's a similar thing, except the exponent's not quite as easy. This one I know is a 2, right? The exponent I raised 9 to get 81 is a 2. So on this, I would take, if I take 9 to some exponent, I get a 3. So that I can write that as 3 squared to the x equals 3 to the 1. So 2x is 1 and x is 1/2. So this represents an exponent of 1/2. And then for this one, same thing, 9 to the x equals 27. So that's 3 squared to the power of x equals 3 to the third. So 2x is equal to 3. I'm equating the exponents. So x is equal to 3/2. So this exponent is 3/2. So if I add 1/2 plus 3/2, that's 4/2, or 2. So then in part C, they want me to state a generalization. And this is what I'm going to say. If I'm adding two exponents that have the same base, what I will get will be the exponent that in that same base. And so if this is a base and some number, and this is a base and some other number, that I will get, notice that in this case, 8 times 4 is 32. And in this case, this 3 times 27 is 81. So I think m times n, whatever those two are, I will get that product of m times n. So it's just saying that when I'm adding exponents with the same base, I can multiply those numbers together to get this. So that actually is one of the properties of exponents, and we'll learn more about it in later lessons.